Nice to see you. Look at all those books you have in there.
Right.
Wow. And it's interesting that we start with books because you've got this textbook that is the number one astronomy textbook that you co-wrote. Am I right?
That's right. So there's a project, Kim, that's a nonprofit project at Rice University with the aim of creating a free introductory textbook for every class that's an introductory class that students take in college. So introductory psychology, economics, physics, and in our case, astronomy. It's our book. The three of us write it. We like to think of it as the first astronomy textbook with jokes,
Mhm.
and it's completely free on the web. Thank you for showing the web page. And we've just learned that 1.1 million students have used it.
Wow.
And so it's now the number one introductory astronomy textbook. And you don't have to be a student to use it, anyone can use it. It's available free on the web at the OpenStax website.
Free. You making this available free to people.
Free. It's the money to set this all up was paid by several major foundations, including the Gates Foundation, and now students have to pay $0. Of course, that means we get zero royalties, but it's a really good feeling that we're able to help so many students.
Well, you're spreading this amazing knowledge and your passion for the subject. And I will say that textbooks, if you're a college student, that'll set you back. Sometimes one textbook can be 200 or 300 bucks.
That's right. This is what has so many students upset because, particularly at places like community colleges and small colleges, where students are really strapped for funds, that can
Mhm.
make a big difference. So, this project prides itself on saving students millions of dollars all over the country on their textbook costs.
Well, let's talk a little bit about what's happening at the beginning of the year because I understand that this new year, 2024, is going to be a big one in the sky. I have an article in front of me that says we're going to see uh, January 3rd and 4th the a quadrantids meteor shower. Is that right?
Yeah, good pronunciation. That's right.
Thank you.
So every once in a while, the Earth in its orbit, as we go around the sun, encounters a swarm of cosmic garbage. That's really the elegant way to put it. It's garbage left over from comets and other astronomical objects that shed, like your pets tend to shed.
Mhm.
Comets tend to shed pieces of dirt and dust. And then when we get into that neighborhood, we get what's called shooting stars or a meteor shower. And the next good one coming up will be Wednesday night, Thursday morning, January 3rd and 4th. You do need to be away from city lights. If you're in the
Okay.
midst of city light or if it's cloudy, you won't be able to see these objects high in the sky. But if you are far from lights and you're able to allow your eyes to get used to the dark, just like you do in a movie theater, suddenly you can see things much better and you'll be able to see more shooting stars January 3 and 4.
That's pretty cool. The Lyrid meteor showers happen in April. That happens in 2024. Also, the penumbral lunar eclipse is coming in March, and a total solar eclipse in April over the US, Canada, and Mexico, apparently.
Well, so penumbral lunar eclipse means that the moon won't get into the main shadow, and
Yeah.
that's unimpressive. So we don't
Oh,
worry
we
about
don't
that.
care about that. Okay.
No, but let's focus on April 8th. April 8th, 2024 will be a total eclipse of the sun, where the moon
Ooh.
gets exactly in front of the sun and blocks its light, allowing its ghostly atmosphere to show, which it never does in normal circumstances. And this total eclipse will be visible in a narrow path starting in western Mexico, coming up through Texas, parts of the Midwest, into states like New York, and then New
Cool.
England. You have to be in that narrow path to see the total eclipse, but everyone else in North America, 500 million people, will see a partial eclipse of the sun, where the sun will take a bite well, the moon rather, will take a bite out of the sun, and that could be visible to, there you see the path. I'll thank
Yeah.
you for that slide. You see the path of where it's visible, but all over the country, you'll be able to see a partial eclipse. And I'm very fortunate to be part of a project, Kim, where the foundation here in the Bay Area, the Moore Foundation, has funded 6 million safe viewing glasses that let you look at the sun
Oh,
during
yeah.
an eclipse or anytime. And that will be distributed by 13,000 public libraries all across the country.
I
And
love
this
that.
is set up. And so if you have a public library near you, you might check with them to see if they're going to be part of the distribution of glasses.
Should I just go in and ask for the Professor Fraknoi glasses?
No, please don't. There's a number of us associated with the project. What you want to do is ask for Eclipse glasses. And there'll be other organizations, NASA and other places will also make available these glasses. But plan on that. It's a Monday morning, April 8th, 2024, will be a big day in the sky because there'll be an eclipse visible all over the country. You'll
Well,
hear much more about that as we get there.
it is really an exciting time for astronomers right now. Not only are all these cool things happening, but we have pictures coming back from the James Webb Telescope. And it seems like every other day I see something incredible over and over again. And um, just pictures of the universe, things, new discoveries, just day after day that are groundbreaking.
Yeah, so here on the slide, you see the James Webb Space Telescope mirror before it was launched. This is a special mirror. It's actually coated with gold. You can see the gold coating there. Very, very thin layer of gold. But this is a telescope that doesn't pick up regular light like our eyes see. It picks up heat rays, what scientists call infrared radiation. It's the heat of the universe rather than the light of the universe that we're looking at. And then when we get the pictures, we translate those heat rays into visible light so people can look at the pictures. But this allows us to look at things that our regular light telescopes don't show us. Cold things, dark things. Here, for example, you see the planet Uranus, which has very faint rings around it. But in heat rays, the rings become really spectacular. Look at that system of
Wow.
rings. Now, Uranus is a planet that's actually sideways. And so the rings are not horizontal, they're vertical. Because sometime early in the history of the solar system, the planet Uranus got kicked on its side. And like many an accident victim, it can't straighten out. But here you see those beautiful rings in a way we've never been able to see them before.
That's really cool. I saw something else today that Christmas tree cluster. Have you seen this? NASA today is putting out a new image. They call it NGC 2264, known as the Christmas tree cluster. It's the shape of a cosmic tree with a glow of stellar lights, young stars aged about 1 and 5 million years old in our Milky Way.
Right. So this is actually a tradition at NASA because
Oh,
the Hubble pictures and the Webb pictures, and there are many other telescopes up in space, uh, produce such beautiful images. Every Christmas, they come up with some image that reminds them of Santa Claus or a reindeer or a Christmas
sure.
tree. So this looks like a specialized image. I haven't seen this yet, but this is a specialized image showing a cluster of stars. And like many clusters, it's got raw material in it. So, one of the most exciting discoveries in astronomy is that the universe isn't finished. There's still a lot of raw material hanging around in the form of gas and dust. And it's out of this raw material that new stars, new planets, new structures are still being made all around the sky. So, in a cluster like this, you see not only stars, but the stuff from which
Mhm.
stars are made. And that's the green, fuzzy stuff that's showing in this picture.
The James Webb Telescope also may have spotted the oldest black hole ever seen.
Mm. Yes, now this is an exciting story. So we know that when stars die, and all stars eventually die over long periods of time, when stars die, they wind up as some kind of stellar remnant. Just like a human being becomes a corpse, there are star corpses. And some star corpses continue to glow for a while, but there's a particular kind of star corpse called a black hole in which the star collapses and collapses and collapses until the gravity of the dead star becomes so strong that nothing, not even light, can get away from it. And if its light can't escape, it'll be black. If you throw something in like a teddy bear, you won't see it again. So we call such objects black holes. And black holes can grow if they eat things. So if you feed a planet down a black hole, it gets bigger. Here actually is the first image ever taken of a black hole. Again, not in visible light, but in microwaves and radio waves. But here you see an image. This actually may not be the scientific image. This may be from the movie Interstellar. So,
Interesting.
but that's what a black hole might look like. And now we're finding big ones,
Yeah.
much bigger than a single star. For example, the center of our Milky Way galaxy. Are you ready for this? The center of our own galaxy of stars has a black hole which has already eaten 4 million suns worth of material. Enough
Wow.
material to make 4
Are
million stars like the sun.
are we concerned that that's in our galaxy and maybe a little too close for comfort?
No, 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 because it's
Okay.
27,000 light years away from us. It's no big deal. But now we are seeing black holes further and further back in time. And here you see an image where the James Webb Space Telescope has found a big black hole that is there only 600 million years after the Big Bang.
Wow.
How did a big, a black hole like the one in the Milky Way with a lot of stuff already in it, how did that form only a few 100 million years after the Big Bang itself? We thought it would take a while for black holes to gather, to eat enough material to become so big. But the James Webb Telescope tells us that somehow black holes found a way to start bigger or get bigger even at the beginning of time. And that's something we're going to be looking at for a long time and trying to figure out.
I have a black hole question that will probably make me sound astronomically illiterate, but I'm wondering if, because you think of a black hole, you think of the front of it, right? And you think that there's maybe nothing behind it except nothingness and blackness. I don't know. Is there a backside to a black hole? Is it eating things from both sides and collapsing in on itself from both sides? I don't
I
know.
want to start answering it by saying that you were unfair to yourself when you introduced this question. That's a brilliant question, not at all an ignorant question. It's one of the most profound questions about black holes. Do black holes have bottoms or sides or tops? How does it work? And actually, we think a black hole is 3D. So think of it like a star. Star is a big ball of hot gas.
Hmm.
When the star collapses, the whole star becomes a black hole, and the black hole is all around. Whichever direction you approach it from, material falls in, and it's a strong source of gravity. So there
Okay.
isn't a place where the black hole goes that's in our universe. We think that inside the black hole, space is actually warped and it just becomes a kind of mini universe of its own. But there's a black hole can be approached from all sides.
So interesting. What do you think what's the most interesting thing to you that we've discovered because of the James Webb Telescope and the images being sent back?
Wow, that's like asking which of your children you like best. That's a tough question, but let me answer it this way. For me, having now spent decades in the field of astronomy, the most exciting thing that's happening in astronomy is that we have discovered planets orbiting other stars. We've always known that our own sun had 8 or 9 planets, depending on where you fall on the Pluto debate. But we've never known whether other stars have planets, because planets are so much dimmer than stars, they were hard to make out. But in the last few, well, now about 25 years, it's not so few anymore. The last 25 years, we have managed to find 5,000 planets orbiting other stars, and we're finding new ones all the time. And what the James Webb Telescope is enabling us to do is not only to find such planets, but to figure out what the air around them is made of, to get the heat rays from these planets and figure out the composition of their outer layers, which is usually their atmospheres. And we're beginning to find some of the building blocks of life
Oh,
in
wow.
the atmospheres of these alien planets. And
Oh,
this is just very preliminary, and we need a lot more work. But
yeah.
already the first few discoveries are hinting at substances which here on Earth we associated with the very first stirrings of life, the chemical mixtures that led to life on Earth. So that's very exciting, that the possibility of life elsewhere is something that we can investigate with the James Webb Space Telescope. And here you see how we find these materials. This is what's called a spectrum. When you spread out the light or the infrared rays from a star or a planet, you can read off the different elements or substances by the imprint they make on the light. Different substances leave an imprint on the light, and we can read off that imprint when we make a spectrum like this. So here you can see methane and carbon dioxide and some sulfur compounds in the atmosphere of this exoplanet or alien planet.
Randy is asking, if the universe doesn't go on forever, what's after the edge of the universe?
Oh my goodness. That's one of the hardest and deepest questions in all of science. It would be one of the Mark Thompson listeners who would ask. That's
We'll leave it
great.
to Randy, right?
Yeah,
Yeah.
that's great, Randy. So this is complicated. Is the universe a place which goes on forever, or does it have an edge? Is there some limit to it? And if so, as Randy asked, what's beyond the edge? When I was growing up in astronomy, this was still an open question. There were indications that the universe might have an end, an edge, and there were indications that it might not. Now, more recent observations indicate that the universe really is infinite. Now, we can't see all of it. We can only see the parts that where the light has reached us,
Hmm.
but it may well be that the universe goes on forever. That's what the most sort of recent and most reliable experiments have been showing.
So interesting. But we'll never know because, again, as you say, we'll never see it. So how do you confirm it?
Well, that's right. It's only from the properties of the universe, the
Hmm.
way light, for example, bends, and the way gravity and the motion of the galaxies are balanced, that we can tell these things. Again, one of the discoveries that I think is really exciting, that has been changing astronomy, is that the whole universe is expanding. All the galaxies of stars are moving away from each other. And that's been known since the 1920s. What we're now discovering is that this expansion seems to be speeding up. And nobody expected that. You know, in your car, that you can coast in your car without giving it extra gas. But if you want to speed up, you got to give your car gas. You got to
Oh,
insert energy into
so
the system.
what's causing it?
What's giving
Yeah.
gas to the universe?
So
What's
interesting.
causing the universe to speed up its expansion? We don't know, so we made up a name for it, because we always feel better when we make up a scientific name. We call it dark energy. Dark energy is this unknown energy that's
It's
making the universe speed up. But what
sounds
that
like the
energy
bad
is, we
side of the
don't
force.
know.
Sounds very sinister.
Yes, dark energy. Right.
Yeah.
Sounds like from Star Wars.
Right.
But if you have an expanding universe that's actually accelerating, then we know from our understanding of the geometry of space and time that must mean an infinite universe. So that kind of connects back to the question.
So Gordon writes in 17 planets have been identified that could support life. Is that true, or have we found anything via the James Webb Telescope or anything else that shows us a planet that we think, aha, there's a place we could go if we ever run into trouble?
Well, so unfortunately, we can't go anywhere in practice if we destroy the Earth. All the planets in our own solar system, if you stepped out on any of them, you would die instantly. So all our neighbor planets are deadly, poisonous. Some of them don't even have a surface to stand on. If you were to land on Jupiter, you wouldn't. You just sink in and in and in and in forever. So now, with these 5,000 planets elsewhere, we have found some that look promising, where they're in the what's called the habitable zone of their stars. And there's a laboratory at the University of Puerto Rico, which is called the Habitable Planets Laboratory, and they keep track of all the new discoveries, and they make a list of how many planets they think might be habitable. Again, not quite the same atmosphere as us, probably not the same temperature that we particularly need, but habitable in some sort of way. I don't know if that number is 17 or 18, but yes, they're keeping track of that. But those stars are so far away that the fastest spacecraft we have ever built would take millions of years to get to them, because they're really far, far away. And so the chances of us being able to move there anytime soon is not very good. We have to take care of planet Earth, because there is no alternate planet. There's no planet B that we can easily move to.
I'm almost out of time, but I wanted to ask you about this huge contribution that came into the SETI Institute for studying whether or not alien life exists.
That's right. So I'm on the board. I've been privileged to be on the board of an organization, a nonprofit called the SETI, or Search for Extraterrestrial Intelligence Institute. And we look for what's called techno signatures, signatures of alien technology, whether it's TV shows or radio broadcasts or giant heat factories, but something that tells us about alien technology. It's now possible to do that. And we were very fortunate that Franklin Antonio, one of the founders of Qualcomm, who sadly passed away recently, has left us $200 million to
Wow.
speed up the search for alien technology, for technology from elsewhere. Not that they're coming here. We want to get them where they live. We want to pick up signs of their technology where they live. And now we will have many new ways to do that. So
So
very
that's
exciting time.
so interesting. If we know they exist, if we find them and we know they exist, do we contact them? And are we sure we want to?
Yes. I write science fiction stories in my retirement, and that's my favorite topic to write science fiction stories about. If we discover alien technology somewhere else, they won't know we've discovered them. This is a passive exercise. But if we then reply, they know we're here. Should we reply? And
Right.
who gets to decide that? Do scientists decide that? Does the UN decide that? Do all of us on Earth get a vote? That's a pretty big question for
Mhm.
humanity. Do we identify ourselves to aliens? What if they're hostile? It shouldn't be just astronomers who decide that question. And that's one of the things we're going to do with the money, is to have international discussions of exactly that question, Kim, that you asked. Who speaks for Earth?
Absolutely. Quick question before I let you go. I have a junior astronomer in my house, and I have it on good authority that a telescope is coming to this household. What's the first cool thing to show a kid when they right when you pull this out of the box?
I think the first thing they'll look at is the moon, because
Hmm.
almost everything else is a little harder to find.
Yeah.
But the moon knocks your eye out, right? So,
Yeah.
and taking a telescope to the moon is perfectly safe. It's not like the sun.
Yeah.
And you can see craters on the moon, ancient impacts that exploded and made these beautiful round holes. So I would definitely start out looking at the moon, and then
Wonderful.
get to know the sky, and you can look at other things. But the moon's easy to find and fun to look at.
Wonderful. Thank you so much. I so appreciate you coming on the Mark Thompson show. And I hope that you will come back. Oh, there's a great picture of the moon. I hope
Yeah.
that you will come back to us again for more discussions about what's going on in the universe and in space, because it's so fascinating.
Well, thank you, and I'd love to be back. I really enjoy our discussions, so thank you.
Happy holidays to you, Professor Fraknoi.
Great, and that was my website.
Hi, it's Mark, and I thought that was great. Hit the notification bell, you'll know whenever there's a new video being dropped, and please subscribe to our channel to help us save the universe.